All right, this is Unit 4, Section 3, Lesson 13, Barely Alive Solution Concentration. Basically, we're going to go over a couple of definitions, all related to solution, and then we're going to talk about how do you calculate concentration within a solution using something called molarity. So first, a couple of definitions. First off, solution, which is the same thing as homogeneous mixture. It's basically a mixture of two or more substances that is uniform throughout. The most common example is Kool-Aid. So here's a glass of Kool-Aid. You take Kool-Aid powder, which is basically colored sugar, and you mix it with water. And you zoom in, and if you zoom in and look at all the specific molecules, here I have in blue molecules of water, and then evenly distributed throughout are the molecules of Kool-Aid. So that's what it means by homogeneous mixture or a solution. Two substances mixed uniformly throughout. Right? You can separate a solution to its main parts, specifically two parts. Solvent is one of them. Solvent is the compound that does the dissolving. So it dissolves the other substance, and most of the time it's going to be water, right? So in this case, if you have a drink of Kool-Aid, water is your solvent. Solute, the other definition over here, is the compound that gets dissolved, right? So the thing that breaks down in this example of Kool-Aid, it's the Kool-Aid powder that's your solute. So Kool-Aid powder is the solute, your solvent is water. There are many types of solutions you can have. A more specific one would be a saturated solution. So that's if and when you have the maximum amounts of dissolved solute in a solvent. So let's say I have this glass of Kool-Aid and I'm going to add Kool-Aid powder until there's going to be a couple of tiny Kool-Aid crystals in the bottom. Then I probably have a saturated solution. So none of these Kool-Aid crystals are going to dissolve anymore. They're just going to sit at the bottom. That means I have a saturated solution. Opposite of a homogeneous mixture or a solution is a heterogeneous mixture. So a heterogeneous mixture is a mixture of two or more compounds that is not uniform throughout. The key thing is that it's not uniform throughout. Basically, all that means is if you have a heterogeneous mixture, they're not going to mix. You can think of salad dressing like oil and vinegar, they're separating out. Right? So that would be a heterogeneous mixture. So those are our definitions. Let's talk about how to calculate what type of solutions do I have, right? So we use the word concentration. Concentration is the amounts of substance dissolved in a specific amount of solution. So it's basically how we measure how much solute or how much Kool-Aid powder is in water, so we know that we have the right amounts for the best tasting Kool-Aid, something like that, right? In this class, we're going to use the units called molarity, which is one of many ways to measure concentration. So molarity follows this equation here in green. Molarity is basically the moles of solute divided by liters of solution. So if we go back to our Kool-Aid example here in our molecular view, it's the number of moles of Kool-Aid I have divided by the liters of water I have. So let's do some calculation examples. How to calculate molarity. So example number 1. What is the molarity of 0.10 moles of NaCl in 1.0 liters of solution? So remember that my equation for molarity is, I'm just going to write this down, molarity equals moles of solute divided by liters of solvents. I'm probably going to need some more writing space, so I'm going to shift this down. Okay. So in this case, my moles are 0.10 moles of NaCl. So I'm just going to write 0.10 moles of NaCl on top. And it's divided by the amount of liters of solvents I have, right? So here I have 1 liter of solution. That's the unit I need. Divided by 1 liter. So if I take 0.10 divided by 1.0 liters in my calculator, I just get 0.10 moles over liters, which would be my final molarity, right? A lot of the times it's a lot to write these 4, 5 symbols. So instead of writing moles divided by liters, you can also write capital M for molarity. So 0.10 capital M as the units. And that would work out as well. That's also the correct answer. And Kat's calling me to play, but we're going to ignore her. All right. Example number 2. What is the molarity of 15 grams of C6H12O6 in 250 milliliters of water? This is a slightly more complicated problem. And in order to do this problem, you need to remember that 1 liter is the equivalent to 1,000 milliliters, if you remember this ladder system that we have here. So when it says 250 milliliters, I'm actually moving it 1, 2, 3 spaces this way to get liters. So it's 2.50 liters. So let's pull up my equation again. Remember that if you're looking for molarity, the unit for molarity, or capital M, is moles over liters. In this case, I found that my liters is 0.250 liters. So this would be 0.250. But I don't know how many moles I have. I only know how many grams I have. So I need to take the grams and convert it into moles. So in my next step, I'll do this in a different color just so that it's more clear that we're doing kind of like a side step. So I have 15 grams of C6H12O6, and I want to look for how many moles I have. MOL, moles. So I need to get rid of the unit grams and find a ratio that has grams to moles. And if you remember from your periodic table, I can calculate the molar mass of this entire compound to determine how many grams per mole I have. So I need to find the mass of C multiplied by 6 because I have 6 of it, find the mass of H on my periodic table, multiply it by 12, find the mass of O, multiply it by 6, and then add all this together. I'm not going to go over that in detail, but I'm going to let you know that you should get about 180 grams per mole. And this is with me rounding to the nearest whole number. So if I take these two numbers and I divide them, I get 0.08 moles. Divide here, 0.08 moles. Take these two numbers and then I divide them. I should get 0.32 molarity.